Hello and welcome back. First of all, I would like to thank you for supporting me in doing this good job. I want you to know that I always try to bring accurate and clear information to you. The sole purpose of me creating these videos is to help you understand those concepts that you always wanted to learn. At the end of this video, if you find it helpful, please do like, comment and share. If you are new to this channel, also hit the subscribe button in right bottom corner. With that being said, let's see what we have got today. Troubleshooting site-to-site VPN. In this session, I'm going to show you the commands that you can use to troubleshoot your VPN problems. Previously, I shared the concept of site-to-site VPN. So this session is going to be all about commands. So let's start with phase one not coming up. What commands do we use? If phase one is not coming up, first thing you do is verify. You have to verify if phase one is coming up or not, right? How do you do that? So you can go back to your CLI and say show crypto IKEV1 SA. Let's say there are no IKEV1 SAs at the moment. That means my phase one is down. In your real-time environment, you may have too many VPN tunnels in there. So on this ASA, I have a VPN setup. So let me show it to you. Show run crypto map. Since we have come to that, let me first show you how do you pull the configuration for your VPN. Let's say your customer tells you that I have a problem with my VPN. On your ASA, you have too many VPN tunnels configured. So how do you find the exact configuration for that particular VPN? Well, in this case, on my ASA, I only have one VPN tunnel configured, but the command still works. You need to ask the customer at least the IP address of the peer. So you need the peer IP. At least they can give you that. So let's say the customer has given you a peer IP, and the peer IP is 1.1.1.2. That's your peer IP, right? Now how do you find the configuration related to this? So you need to start looking at the crypto map. So you say show run crypto map pipe include peer IP. That tells you that you have a crypto map for this particular peer that is applied at number 10 in my map crypto map. Now you need complete configuration for this particular crypto map. So then you say show run crypto map pipe include the name of the crypto map, my map, space, and the sequence number. So my map 10. This gives you complete configuration for crypto map related to this VPN. The crypto ACL name is AWS VPN. Set peer IP is 1.1.1.2, and the transform set is my set. If you need to look at more configuration, then you can say show run tunnel group, and the tunnel group name will be of course the peer IP, so 1.1.2. In the tunnel group, you can find what group policy is applied. So to check the group policy, you can say show run group policy 1.1.1.2, and that shows you group policy configuration. In the group policy, you can see there is a VPN filter applied. VPN filter name is AWS underscore VPN underscore filter. So VPN filter is actually an access list. So to see the VPN filter, you have to run the command show run access list and the name of the access list. So that shows you what is in the filter. That's how you can look at the complete configuration for a VPN. Right? If you need to figure out what are the policies, phase one and phase two policy. So phase two policy is in your crypto map. The phase two policy name is a transform set, my set. How do you look at it? You know the transform set name now, right? So you say show run crypto IPSEC pipe include my set. So that shows you what is there in your transform set. So in your transform set, you have the transform set name is my set, and you have encryption as AES and hashing as SHA. Right? That way you can look at the transform set. Now if you need to look at phase one policies can be a little confusing because you may have multiple phase one policies configured, and the phase one policies are not actually binded with anything. So any phase one policy may apply to you that matches on the remote side, but you can still look at all phase one policies that are configured. The command will be show run crypto IKEV1. That tells you you have one phase one policy number 10, and it has these parameters configured. It also shows you if your IKEV1 is enabled or not. These commands will help you to figure out the related configuration for your VPN peer if you just know the peer IP address. So if you just know the peer IP, that my peer IP is 1.1.1.2, then you can start looking at the configuration of the VPN using this command show run crypto map pipe include your peer IP. This will tell you if you have any configuration for this peer IP in your crypto map or not. And it also tells you if you have a configuration that's on, what sequence number is it using in the crypto map. Once you know that, you will know the crypto map name and the sequence number. So you can run the same command again, show run crypto map pipe include crypto map name, my map, sequence number 10, right? That I obtained from the previous command. And this gives you complete crypto map output for particular peer. Once you have seen that, in the crypto map, you will find the crypto ACL that it tells you the interesting traffic. You'll also find the peer IP and the transform set name. Then you can look at the tunnel group, show run tunnel group 1.1.1.1.2. Too many times I said 1. You can look at group policy. So group policy can be obtained from the tunnel group. In the group policy, you may or may not have a VPN filter. So if you do have, you can look at it by using command show run access list and the filter name. If you need to figure out what policies are sent, what policies are configured for phase 2, then phase 2 policies are applied in crypto map. From the crypto map, you get the name of the transform set and then look at the transform set. So the way to look at the transform set is show run crypto IPSEC pipe include transform set name. In this case, it's my set. If you need to find what phase 1 policies are configured, then you can say show run crypto IKEV1, and that shows you all the phase 1 policies configured. Remember, ASA sends all phase 1 policies, whatever you have configured on the ASA, and whatever matches on the remote end, that gets selected. So you can't really say, can't really decide on your own which policy will match. Coming back to how to verify if phase 1 is up or not. To verify phase 1 status, you say show crypto IKEV1 SA. It said there are no IKEV1 SAs, that means phase 1 is completely down. But if you have some continuous traffic going on and maybe there is a problem with your VPN configuration, VPN isn't coming up properly, so you might want to run this command multiple times just to see if it's trying to come up and going down, trying to come up and going down. And you might want to run it quite fast because this might be happening very fast. Really not happening, nothing is happening, right? So you see my VPN is not trying to come up at all. Show crypto IKEV1 SA is the command to check the status of the phase 1. Now I'm going to initiate some traffic and then we check the status once again. From this PC, I'm going to initiate a ping to a remote end IP address. The remote end IP address that I want to ping is this one, 10.10.10.20. Things are down on this side, this router is down. I'm not really interested in getting a successful ping. All I want is an interesting traffic for my ASA to attempt a VPN, because both the ASAs are up. Okay, so here we are. I want to ping 10.10.10.20 and make it continuous ping. So the ping is going on, timing out as expected. Let me come back here and run the show crypto IKEV1 SA command again. So you see it says I'm trying to establish VPN with peer IP 1.1.1.2. My role is initiator and the state is wait message 4. So this gives you an idea what's going on. This command helps you to see the status of phase 1. Now, to understand why it is showing wait message 4, I've already made another video, so you can go back to previous videos and check that out, why it is showing wait message 4 and how to troubleshoot this problem. But the purpose of this video is to show you the commands to identify the issue. How do you figure out what is the problem? So you do debugs. The debugs must be applied conditional. To apply conditional debugs, you will say debug crypto condition peer and the peer IP 1.1.1.2. Once the condition has been applied, then you say debug crypto IKEV1 and the level of debugging that you would like to do. So I usually do 128. That gives me enough information. And then to stop the debugs, you say undebug all, or quick. If you have to type it too quickly, then you say unall, and then that stops the debugs. Let me quickly fix this problem. In this one, looking at the debugs, I have a feeling that appreciate key is missing. So it's missing on either end. So let's see if the appreciate key has been even configured or not. It looks like the appreciate key is not even configured. So the appreciate key is configured in tunnel group. I check the tunnel group configuration, show run tunnel group, and the tunnel group name is 1.1.1.2. So there is no appreciate key. I'm gonna go ahead and configure that. See tunnel group 1.1. And it's in IPSEC attributes, IKEV1 appreciate key, and ta-da. Let me check on the peer as well. Show run tunnel group 1.1.1.1. There's no appreciate key either. So tunnel group 1.1.1.1, IPSEC attributes, IKEV1 appreciate key, and bam. So let's save the configuration. Check the tunnel status again. Show crypto. Yes, you can also say show crypto ISECamp SA. It might not accept your command ISECamp in the newer versions. If you type it, it's gonna take it, right? So it says active, and that was the problem. The appreciate key was missing. You can also see, same output can be also seen with the command show crypto IKEV1 SA. Right? So no difference. On the newer versions, when you do show crypto ISECamp and hit tab, ISA and hit tab, it will not automatically complete the command because the command is no longer available. But if you just type it this way and hit enter, it's gonna accept it and show you the output. So if you're comfortable typing this command, use that, or you can go for show crypto IKEV1 SA. The end result is same. Right? This tells me my main mode is active. Main mode is phase 1. So phase 1 is active now. Let's say when you run the command show crypto ISECamp SA or show crypto IKEV1 SA, you do not see any status here. Okay, another problem. Let's say you have two ASAs, right? ASA1 and ASA2. There is site-to-site VPN. There are two PCs connected here, right? Let's say this PC's IP address is 192.168.1.10, and this guy is 10.10.10.20, right? So 1.10 is trying to ping 10.10.10.20, right? You have access to ASA1, and you're running a command show crypto, let's see, show crypto ICKMB SA, or you can say if I say show crypto ICKMB SA or show crypto IKEV1 SA, it's showing me no, there are no IKEV1 SAs. You can also say show crypto IKEV1 SA. You might have seen that I hesitate to type this. I usually use show crypto ICKMB SA. So there are no SAs. Let's run the command once again. Quickly, fast, very fast. Nothing is there, right? What do you do next? So if you don't see any output from this command, show crypto ICKMB SA, you know your VPN will only come up if there is an interesting traffic. You are saying that you are continuously running a ping to this IP 10.10.10.20 and your source IP is 192.168.1.10. So my customer said, I'm running a ping from this IP to this IP and it's not working. So I came to my ASA and checked show crypto ICKMB SA. I see there are no IKEV1 SA. The tunnel is not up. So what's going on? Maybe he's not initiating the traffic, or maybe his traffic is not reaching the ASA, right? So I first need to verify the configuration for this VPN. So I will ask what's the peer IP. He says the peer IP is 1.1.1.2. So I say show run crypto map pipe include 1.2. Now I know the crypto map sequence number, so I say show run crypto map once again. This time I filter with my map sequence number 10 so that I know the crypto access list name. Then I say show run access list and the access list name. So that shows me the interesting traffic that is supposed to go through this VPN tunnel. Customer said he is running a ping from 192.168.1.10. I don't see 192.168.1.10 here, or 1.0 network is not there. But I do see 10.10.10. network here in the destination. So the next thing you do is run a packet tracer. Packet tracer for what customer is saying. So customer says he is running a ping from 192.168.1.10. So you should first know this IP address is behind which interface. So on your ASA to check the interfaces you say show IP. Interface I have inside, outside and management. So of course I don't think, I won't give anyone access behind management. Outside is my internet facing and inside is the only one remaining. But you can however still check the routing. So it says show route 192.168.1.10 and this says it's reachable via inside, right? So on my inside, let's do a packet tracer now. So bring the access list once again in front of your eyes. The packet tracer input inside. I wanna do for ICMP packet tracer input inside ICMP. What is the source IP? So customer says source IP is 192.168.1.10. 80 is the echo request and destination is 10.10.10.20. I want a detail output. So here, let me clear the screen first. Here, the phase one, it says there is an unnat. What this unnat says, I'm hitting a nat statement. So this is the nat statement that's getting matched. It says untranslate 10.10.10.20 to 10.10.10.20. That means do not translate. And then it says access list drop. So if you look at this NAT, it says the real IP is 192.168.1.10 and it's changing that real IP to 172.16.1.10 when the destination is 10.10.10.20. So your real source is getting NAT on the ASA and changing to 172.16.1.10. So customer is not aware of that, right? But I think this matches with your crypto ACL. right? In the crypto access list, we have 172.16.1.0, and this IP address is getting NAT to 172.16.1.10. So that's of course one IP from this range. So this traffic, will of course match this crypto ACL, but here from the packet tracer command, you see that it's dropping it because of an access list, right? So the traffic enters from inside interface and is getting dropped because of an access list. Now you need to figure out, is there any access list on inside interface? So how do you do that? You say show run access group. This command shows you if what access lists are applied on which interfaces. So we're interested on inside interface. On inside interface, I have an access list whose name is inside out. So I want to look at what is there in this ACL. Show access list and the ACL name. So this access list allows traffic between two hosts, 192.168.1.10, that's our real IP, to 10.10.10.10. But we are trying to ping 10.10.10.20, and that is not allowed in the ACL, right? So that's another way to, packet tracer is your best friend when you're working on the SA. So let me quickly fix this problem. Status once again, show crypto IPSEC SA, and the phase one is up. So it says state active, which means main mode is active. Main mode is your phase one. Phase one is up. So that's how you check the tunnel status. If there are too many VPN tunnels configured on your SA, like usually there are hundreds, 200s of tunnel, right? Then if you simply say show run, sorry, if you simply say show crypto IPSEC SA, it's going to give you a list of all these tunnels that are up, and it's going to be very difficult to figure out where is your particular VPN tunnel. So the way you do it nicely is show crypto IPSEC SA pipe begin and peer IP 1.1.1.2. So it's going to only show you the output beginning from where it matches this IP address 1.1.1.2, right? That way you can see the status of your tunnel. If required, you may also do a capture on outside interface between public IPs. If your phase one is not coming up and you're not seeing anything in the output, you're not seeing anything in show crypto IPSEC SA, but packet tracer says it's going over the VPN. Let's run the same packet tracer once again that we were trying earlier. This time packet tracer phase 9, it says VPN encrypt allow. So this is the phase type VPN. If it says encrypt allow, that means ASA is trying to send the traffic over the VPN. While it says VPN encrypt allowed, your ASA is trying to send the traffic over the VPN, then there is a phase 10 that's saying access list result drop. And let's see the final result as well. So the final action is drop. So it's getting dropped due to an access list. But if you see the subtype that says filter AAA, so this filter AAA is, any guesses? Filter AAA is your VPN filter that's applied. So I have a VPN filter applied, right? If I was not aware, then packet tracer output can clearly tell me. So if you are seeing filter AAA in your packet tracer output, that means there is a VPN filter applied. VPN filter is applied where? It's applied in group policy. So I need to look at the group policy. Show run group policy, and group policy name is usually the peer IP. So I have a group policy, and in the group policy, yes, there is a VPN filter. VPN filter value is, the name is AWS VPN filter. This is an access list. Right? So my traffic is being dropped due to this particular VPN filter. So I say show access list, the ACL name. This access list allows traffic between 10.10.10.20 and 192.168.1.10. That looks correct, doesn't it? Well, that's the common mistake people make. If you remember, this is the real IP. First thing, VPN filter is always applied in reverse direction to your crypto access list, and it must be exactly replica of your crypto access list, the reverse replica, right? That means whatever you have the source IP in the crypto ACL, that becomes destination here, and the destination becomes source. Of course, then you can limit using protocol. You wanna allow only TCP, UDP, ICMP, you can do that. I must match the crypto ACL in reverse order. So let's look at the crypto access list. So this is the crypto access list. It doesn't match. Does it match anyway in the reverse order? No. In the crypto ACL, nowhere we have 192.168.1.10 because that's the real IP. And the traffic that goes over the VPN gets natted to 172.168.1.0 network. So this VPN filter must have the natted IP. So I'm going to correct that and fix the problem. So without that, let's get rid of this command. Alright, let's look at the VPN filter once again. And this time it does seem to have correct information. Let's run the packet tracer again. So I say packet tracer, this one, and go to the end. So final action is allow now, right? And if you go through the phases once again, so you will see phase 9 VPN encrypt allowed, and then phase 10 is, it's not compulsory that phase 9 will always be VPN and phase 10 will always be your filter AAA. It may vary simply. It depends on lots of things. Phase 10, you see this time filter AAA is allowed because we corrected the information in there, right? And then you look at the final results. Action is allowed. Coming from inside, going via outside, getting encrypted. All good. So if you're not seeing anything anywhere, then of course you can do a capture between the public IPs to see if your ASA is even trying to make any connection attempts to the peer, right? The way you do capture is you just say capture, so capture name. So the name must make some sense. So if I'm doing it on outside interface, I say cap out, capture cap out interface outside match. I want to match IP host. I want to do capture between these two IPs 1.1.1 and 1.1.1.2. Right, so these are the two IPs I want to do capture. Once you apply this capture, it's automatically bidirectional. You don't have to do it for 1.1.1.2 going to 1.1.1.1. No, automatically captures bidirectional. If I just say show capture, that will tell me if what capture is applied and is it capturing any traffic. So it say yes, it's capturing 1930 bytes. Let's run it once again. So it's increasing, that means it's capturing the traffic. If I need to see what is in there, so I say show capture cap out, the name of the capture, and I can actually see the traffic in there. So 1.1.1 is sending traffic to 1.1.1.2. The type is IP protocol 50, and then there is something 1.1.1 is sending to .2 on UDP port 500. So you see UDP port number is 500, right? So this way you can look at these captures as well. There may be some other problems that your ASA might not have enough licenses, or maybe all the license that you had for a site-to-site VPN have been already exhausting. Right? So how do you check that? So you can say show VPN session DB license summary. That shows you the status of the licenses. Right? So we are interested in this one, other VPN. We are interested in this one, other VPN. Capacity 250. So this is device capacity, the maximum capacity of the hardware that I'm using. Is it enabled or disabled? So you can look at the status. And how many are installed? So I have 250. This comes by default. Right? Limit, is there any limit applied? None. So there might, there are commands to even apply the limit. So there is no limit applied here. Same way you can look for your AnyConnect licenses if you have to. So all the licenses are available here. Sometimes you might, if you're configuring VPN for the first time, so you have to have the license for encryption, which is to enable AES DES 3DES on your ASA. Okay. So if you've done everything right and your VPN isn't coming up, but there might be a reason that you don't have your encryption licenses enabled. Okay. So you can, using this command, you can look at all the licenses, and it also gives you the license usage summary. So in my case, I'm using one license for site-to-site VPN. All in use, one. Peak in use, one. So maximum there has been only one VPN tunnel. How many are currently in use? One. Yeah, of course, usage is 0%, and 1 out of 250 is how much? So I think these are the only commands that can help you figure out the problems with phase 1. That's all for now. I hope this has been informative to you, and I would like to thank you for watching it. It is your support, your likes, comments that keep me motivated for bringing up more stuff like this. Please let me know if this has helped you. If you are new to this channel, also hit the subscribe button in right bottom corner.